Hi guys, my name is Benga Ayelabola. I'm a data analyst, and in one of my recent posts, particularly on LinkedIn, I highlighted the benefit that comes with creating a normalized model out of your table, right? That is denormalized, and of course the benefit that comes with having such normalized model. So I did also mention that I was going to share like a follow-up post, which would typically walk you through the process, of creating a normalized data model out of your very, single fact table denormalized model, especially in creating, a very scalable data models in your projects, one that you can grow, right? Or that can grow with your business requirements as it were. So this video will be very short one that will just typically walk you through the process, of creating a normalized model. So in jumping right into it, of course, the very essence of this video, as I said, will be to help or give you a walkthrough on how to create data models from in your next data analysis project. So why should you really care about creating a normalized model, or why should you normalize your data models, right, in your next data analysis project? Before I go on, I think it makes sense to actually explain very briefly what does a normalized model looks like and versus a denormalized model. So to start with, this is what you have, right? For most tables that you probably or models that you're exporting, say from a CRM tool, an HRM tool, a sales tool or a sales funnel tool, that you're just generating from a software. So most of the time it's going to come in a very single fact-based, lump sum kind of model, right? Mostly will be a single model, single table with several measures and entities, right? Which would obviously could be hundreds of thousands and could grow as high as millions of records of transactions, right? That is happening maybe perhaps from an e-commerce platform. And you're required as a data analyst, of course, to derive insights for the purpose of influencing business decisions for every organization or businesses that you're working with. So this is typically what that table, of course, that this is what it's going to look like. It could be on Excel, it could be, on a CSV file. By the time you pull that on your Power BI, in your data view, your model view, this is what that table would look like. Of course, it's going to be a single model, and then most of the times, if you go ahead to start, creating your visuals out of this, that would ultimately impact the performance of your reporting, and of course would be very difficult, or inflexible to manage and maintain. So this is, on the other hand, what a normalized dimensional model looks like. So it is one that you can, obviously, as it is, you can grow it, you can scale it, you can create more measures, more filters, for the purpose of quicker, you know, creation of your reports and building up ultimately, your dashboard. So with that in mind, that explains to you that, normalization is a process of, working from a denormalized table, a single fact table, breaking them down into component parts of dimensional and factual tables. So the dimensional tables basically represent, all the tables that are connecting to the fact tables, which you broke them out of the fact table. So the dim location, the dim segments, discount bound, dim date, and all that. They're basically dimensional models. They're called dim models, whereas the table that has the measures, that has obviously, the measures or the figures would particularly also come with a lot of duplicates and all, and several records and all that. So that's called the fact tables. The fact table could be joined to the dimensional table either on a star schema as it is presently, or through a snowflake kind of schema, which I probably would also do another video as to typical scenarios where you could have a fact table linked to the dim tables through snowflake, and then we'll just look at a very simple example in that, maybe in another video. But again, from what you saw in those two scenarios, that obviously would represent the fact that some of the benefit that comes with normalizing your models, right, from a very single fact table, heavy table as the way would be one. You're improving your data quality in the sense that you're able to have a very quick insight, quick view of how your table or structures within your table looks like. Of course, that gives you insight as to being able to identify quickly or quicker, things like duplicate records and several other things. And then, of course, simplify data management that helps or allows you to be able to grow the data. As where you can grow your tables, you can, in the very future, if there are new segments or if there are new categories within your transaction, it's easier for you to manage as aware. Data redundancy, in the sense that if you have multiple records that are duplicated in your table, right, it pretty much makes sense to normalize your table for the purpose of quickly seeing where duplicate records are, and that obviously will reduce redundancy as well, because records that you don't need, you can get rid of them. And of course, a few other it makes your project very logical for business analysis, and of course for the stakeholders to also read and understand. Yeah, so you saw what the normalized model looks like versus a denormalized model, right? So in this video, you'll see that I'll use very interchangeably model, data sets, or query. So I'm referring to being again to the same thing, because the context of this demonstration would land mostly around, or will revolve around, Power BI, right? So when I'm saying data sets, model, tables, I'm referring basically to the same thing. Right, so for the purpose of this demonstration, the data we're going to be using, right, the sample data source will be gotten from this Microsoft Learn platform. So safe to say that it's important that you know that you have to either log on to your account or create an account if you don't have one, right, on Power BI. So I'm going to go ahead. Remember, what we're trying to achieve is to seeing that we have basically a table or a record or a sales record that looks like this, and we are ultimately working towards achieving something that looks like this, which is called a normalized model. Okay, so without further ado, let's get into that. So I'm going to head on to my Microsoft page that has the sample data, and we're going to just go ahead and download that. So ensure that you go ahead to download. So this is what you would get if you navigate to that link, right, that I highlighted to you. You'll see this platform. So just go ahead and click financial. This is the financial sample Excel workbook. So I'm going to download that, and you have that on your system. So this is what that file looks like. It's a very simple, for the purpose of quicker demonstration, has only about 700 records, right, or less than that, about 700 or less records of sales transactions. So I mentioned to us that in the write-up, right, which is attached to this, which comes with this video, that it is important that you identify, or rather understand the context of this project. So context is very key, as you already know, when it comes to data analysis. So context in this sense would mean that typically you'd first sit with the, of course, the stakeholders, understand the data, right, understand what is important to the business from the data that you have. Important that you know that all the records or all the information in a table or in series of tables would not necessarily be important, to the business. So the business would typically or you sitting with the stakeholders would mean that you identify, what are the important thing about the record that or what are the business questions that will be required to answer from the tables or the analysis you're trying to perform. So with that in mind, the next thing you then do, so as I said, this is what that file, if you download that, this is what it looks like. The next thing would then be to create like a conceptual model. So the process of data modeling start first with conceptual modeling. There are about 3 types of data modeling. So you've got conceptual modeling, you've got the logical modeling, and then you've got the physical modeling. I'm going to be walking you through the 3 process, of creating each type of the model type, right? Or each data model type, as it were. So now we have this file. So I'm going to go to, as you saw here, right? We're going to first start with creating a conceptual model. So how do we create that conceptual model? To understand first, is mostly talking about at a very high level, right? Information around your table, right? This is you breaking down your table into segments at a very high level for the purpose of maybe sharing the information with the stakeholders for them to have an understanding, or perhaps to also review and give, comment around segments within your table. So this is you breaking down your table at a very high level, right, for the purpose of documentation, for the purpose of sharing that, with the required or with the identified stakeholders involved in the project. So I'm going to head on to this site, which is draw.io, and I'm going to be, so this is draw.io, right? You just create, so if we head on to draw.io, loads this place, and then you go to create new diagram, select blank diagram. You can give your project's name, right? So if I'm giving it a project, I could call it, of course, the table or the kind of models you're trying to create will suggest what name to choose, right? So I'm going to create that, and then you click create. Make sure you select blank and then create. So with that done, you would have, this blank page for you to create your conceptual models. Remember, if you look at the table we have, basically it's a record showing different sales transactions of products, right? So safe to say that this could be like a sales record, right, showing different sales transactions across years, months, and several other measures as it were. So that represents first your fact table, because your fact table is that table that has either measures or that gives you a very top level kind of information about your table, right? So the very table that you have is the first fact table. So the fact table in this instance would be to identify first, what does this table really suggest? What does it really mean, by merely looking at it? So if you look at that table, it's a table that talks about, sales transactions of products, right? So I would then come down, right? Scroll down from this point. You probably would be on general. So you want to collapse that and move to your entity relation, because again, we're creating relationships between one and several other tables. We're saying that there are 2 types of tables. We have the fact table, as in FACT, and we have the dimension table, which is the DIM table. The fact tables are the tables that give the top level information about a particular data set that you're looking at, whereas the DIM table or dimension tables would represent basically the categories, the segments, the filters that you can draw from your fact table. So I'm going to first then say I'll just pick an entity, right? Pick an entity and drag it to the very center of your table, of your page. So very quickly, I'm going to call this very one to call it fact sales, because as we said, it represents sales records. And I'm going to duplicate this, right? And a few duplicates, right? And then you would go back to the table which you have to identify what are the easiest to get from here, or in getting your dimension table, is just to ask a few questions which you probably had asked earlier on while meeting with the stakeholders. Or if you have not, you could also ask those questions yourself, and then whatever dimension and fact table you create, you can obviously share this with your stakeholders to validate or confirm that this answers some of the questions that they would like to see. So merely looking at the table, right, one of the things that would interest me as a data analyst is seeing the sales transactions by segments, right? So segment becomes your first, could be your first category, and by that, or by inference, could also mean your dimension, your first dimension table. So I'm going to call this dim segments. All right, so what would your segment typically contains, right? If you go back to the table, your segment would contain first the segment. Is there any other information in the table that suggests or points to the segment? If yes, add that as part of the attributes of segment, right? So, but right now we only have segment. There are no other information that infer segment. So I'm going to leave this as segment, and the attribute first one I'll call is segment, right? But because it is important that for every dimension table that you're creating, there is like a unique code or a unique ID which can point back to the fact table. All right, so because we don't have a unique ID, I'm going to create it right myself. So how do I create a? Very simple. Remember, we are not doing any intriguing thing other than creating just the flow, right, which is at the very high level. This is a conceptual model. So I'm going to call this segment ID, which would mean that I would have to create something called segment ID within my dimension segment. All right, so I'm going to leave this as this. Then I'm going to now, but remember that a single segment within the dimension table could translate to several records within the fact table, within the fact sales table, right? For instance, if you look at this, you have government. Government record could have several, you know, representation within the fact table. Remember, this is a fact table, so there are government, and several other government. The same mid-market could appear in several places in my fact table. So what relationship do you think that would be? This would be a one-to-many relationship, right? So I'm going to bring in here the relationship and draw that relationship like this. All right, so I'm going to draw the relationship this way, and we're going to then go on to look at the second dimension table. How else could you categorize this fact table? I could categorize by country, right, which is location. So I can call this dim location, right? So if I want to look at all the sales records by location, so we're going to call this dim location. And how would you recognize location? How would you first categorize location? By country, right? So the first attribute in that would be country. So I'm going to call this country. I'm hoping that this will be a very short video, right? So country, are there other information that we can tie to country within this table? So if I scroll all the way, right, there's nothing like country code or city or any information that can be tied to the country, right? So I'm going to leave that as country. But remember, we said that we need something to bind us back to the fact sales. So I'm going to call that country ID. All right. So you get the gist. So this is typically how that process looks like, right? I'm going to then also, again, remember what relationship would we have here. So we're going to have, again, one-to-many relationship. So always ensure that in creating or in normalizing your table, you always have a one-to-many relationship between your dimension table, right, which is your dim table, and your fact table. It's very important because that way you are avoiding duplicates. You are also ensuring that you have integrity within your records, right? Always important that you know that. So fact table, we've got dimension, location, dim segments. What else can we see here? So we can see discount band, right? Because it's another category. I might be interested in seeing the sales record by discount band, say by low band, high band, medium band, or general band, or non-band, as it were, right? Which is could be boundless kind of segment. So I'm going to create another one. So I basically just Control D to duplicate and just Control D in that. So when I do Control D, I'm going to duplicate what I have. So I'm going to bring this here, and then we'll call this. We're going to call this one dim bound, right? So we'll call this discount bound, discount bound, dim discount bound. And how do you have that? So we have first the discount bound, discount bound, and then the next thing will be what? Discount bound ID. So if you have within your fact tables, you have a unique ID, say discount bound ID, right? It means that you don't need to manually create it by the time we're creating, the physical model, as it were. Okay, so I'm going to call this discount bound ID, right? And already the drift, so I'm going to duplicate this, and I'm going to say this is the relationship between this table and this table, right? So then lastly, we have, if I still move on, you can categorize the same table by how else you can categorize them by product, right? This is product here. You could categorize the sales transaction by product. So if I categorize by product, I would also, again, as you would also create another dimension table called dim product. So let's call this dim product. Dim product. Dim product will you would have typically product. And if you look through the table, there's nothing called product ID. So again, we're going to create it manually, and we're going to call this product ID. Product ID, right? So with that in mind, so we currently have one fact table. We have these tables of 4. Now you could also be interested in seeing that all the other tables are mostly measures. They're just numbers or figures. So if I look at another classification here, could be year, right? So year could be another classification. So if I come here, I could have dim dates, control, and then we have dim dates. So if I have dim dates, and I basically would also have just date, right, as a unique identity. So we have date, right, as a unique identity. So because it's date, right, I don't need to create a dim ID, because I know that dates would typically be a unique identifier, within my my as a relationship between my fact sales and dim date. So I don't need to create a dim date ID or an ID, unique ID for my date, because why date in itself will be unique, right, across the fact sales. So, and because I'm also going to be, as you would notice, or as you would see, rather I'm going to be creating a dimensional model for date in itself that we can import and create a query for that. So that's how I'm going to handle this. But for now, again, create your relationship, right, between the other control D, between the other dimensional tables. So I'm going to create this. I'm going to move this here a bit. I'm going to create that. I'm going to bring this here a bit for space, and then this would go. This could still come here a bit. Could draw that, and yeah. So I'll typically just create something like this, and of course this could be here. I could control D this to have for dates and pull that here, right? So I have what you would rather call like a star schema, right? Because if you move all this here, because we have some more space towards the center, so if I move them here, I can rather then design this pretty much in a star kind of way, star topology, right? And then this could go up. I'm gonna move this up. Sorry, I'm gonna move this up. I'm gonna also move this up, right? We can basically have a star kind of topology. So you can still keep this here, and then this could be here, this could be here, right? So with this, I have what you call the I've created a conceptual model, right, which I in turn can share. So what you have typically under the fact sales will be every other information like your COGS, so I can have my cost of goods sold, I can have my, discounts, right, which are basically just measures, right, discounts, and then plus every other, uh, you know, um, every other measures like profit and sales and every other thing. You would have them typically listed out here, but for the purpose of demonstration, what is also very important that you had will be the keys, which in this case will be the foreign keys that are pointing to primary keys in other tables. So these are dimension tables. Remember, they have unique identifiers. So each of the unique identifiers will be what you would then bring in here to say you have segment ID. So I have segment ID. I have, I could just, in each of them, you can copy typically all the IDs from each dimension tables. So I've got one ID here. I've got also the I've got the dates, right, as an identifier within the date. I've got also country ID, and lastly product ID. So once I'm done with this information, of course you can also resize this. You can resize this if you're running out of space, and then grow that as it were. So with this information, I'm able to then export this and share with my whether it's my line manager or the stakeholders for the purpose of getting in a go ahead or a review of this information. You can typically export to PDF or share in PNG or whatever format, right? So once that has been done, export that, download it, and then share with the stakeholders. So this is what that looks like typically, right, by the time you're sharing this with your stakeholders. So this is a star schema arrangement for your dimensional model. So this is conceptual. So I'm going to now use this information to create the logical and physical model using Microsoft Power BI. All right, so let's go ahead and load the data to Microsoft Power BI. So I've loaded the data, right, to Microsoft Power BI. Again, to go through that process again, let me delete the table or the model, and we're going to import that by coming to, because the file that we downloaded, the sample file downloaded, it's an Excel file, right? So I'm going to come to Excel workbook. If it's say a different file, you know that you're definitely going to use your get data, right? So if I go to the get data, this is where you're going to pick whatever data type for the analysis. All right, so I'm picking again Excel workbook, and this is the financial sample. Has typically one table. There's just one worksheet, right? The other one is so the first one is sheet 1 of financial. So what could be important that you check for is what is the exact name of the sheet you're importing. Remember that this is sheet 1, so this is how you want to ensure that you're picking the exact sheet, which is your sheet 1 as it were. and then I would transform. As you know, rule of thumb from Microsoft Power BI, you always do your data transformation, which is part of your, your ETA process, your extraction, your transformation and loading of your data. So always transform your data for the purpose of, cleansing your data or transforming your data as it were. So with this, now we have, as you saw, what you're seeing right now, we have one single data table, right, which is a fact table that we're trying to change from a single table to a dimensional table that would have the fact tables and the dimensional tables as well. So let's go ahead to see what that process looks like. So because I know that I have typically, right, I've got 1, 2, 3, 4, 5 dimension tables, right, and 1 fact tables. So remember, we're saying that I said that I was going to show you how you can basically create, your dim date using some set of queries, Power Queries or hem query language within the Microsoft Query Editor. So I'm not going to create this manually, right, but I'm going to create basically 4-dimensional tables out of my fact table. So let's look at that process. So first thing, let's rename this table. So this table is called the fact table because that's the table that has the fact sales record. It has the factual records, which are measures for the transactions. Why I'm calling it sales is because of the kind of entries that I have in this data, right? It's basically like a sales transaction kind of table, right? So that's why I'm calling this as the first table, which is the fact table. So I'm going to go ahead and duplicate, because remember we need 4 other tables which would act as the dimensional tables according to our conceptual model. So I'm going to duplicate, right click on this and duplicate. By the way, this is the Microsoft Power BI Query Editor, which is the platform for doing your transformation of your data and cleaning of your data as a way to basically do some data wrangling and to ensure that you properly clean your data before you start building your report. So let's go ahead and create 4 duplicates. Duplicate 2, duplicate 3, duplicate 4, and that's it. So remember, the first duplicate name we said is dim segment, so I'm going to call this dim segment. And we have dim discount bound, right? Dim discount bound, which is mostly would mean this is how you would see all the sales transactions by discount bound, right? Dim discount bound. Then we have the products, right? Dim product. Then we have the dim location, right? So dim location, double click on that and click dim location. So now we have our 4 dim tables and 1 fact tables. So let's go ahead to start looking at drilling down each table into the proper record that it should show. And then remember, we're saying that we also need to manually create, because none of the dimension tables have specific models or specific columns or attributes for identifying them, right? So it's pretty much important that you create like a unique identifier or unique IDs for each dimension table that you can in turn point back to the fact tables, right? So that is what we're trying to do here. So I'm going to go here, starting with the dim segments. First, of course, on the identifying that each of the columns have the right data types. That is important. Why I'm not going ahead to look at that is because pretty much all the data types have all the columns or attributes, right, have the right data types. Again, if they don't, you want to ensure that you right click on each of them and choose the right data type for that. You know that already. So going back to the dim segment, so I'm going to start first with the segment. As we've established, it's only segment that that points to itself right here. So there are no other columns from these tables, right? This table that points back to segment. So segment is just on its own, right? So I want to come here because I need to delete every other tables. But how you would go ahead to do that, very important that you pay attention here. Don't delete them, right? Because you don't know what you might want to do with them later on. So this is how you're going to do that. We're going to choose colons, right, from the home. I'm going to deselect everything and choose only the colons or attributes that represent the current dim table. All right, so in this current one, it's only segments, country, product, every other information are just on their own, right? So I'm going to pick just the segment and then click OK. So now every other record goes away, right? But if you look at this table, typically you'll see that there are probably duplicates, right? A lot of duplicates, transactions or records in this current table. So I'm going to right click on this and I'm going to say remove duplicates. So right now we have uniquely 5 records, right? 5 segments as it were from this record. So how do we create unique identifier for this segment? Very simple. So if you go on to your hard colon tab, right? In the hard colon tab, there's something called index colon. Don't click on directly on the index colon, but there is a small drop down button, right, just beside the index colon. So I'm going to click on that. Rather than choose start from 0, I'm going to say start from 1. So now government would always have one record, one identifier, one as identifier or as the ID, right, or as a surrogate key or as the index key. The same applies to enterprise. Would always be 4 wherever you're calling for enterprise, or wherever you call for 4 within the segment table, what comes out? Enterprise. Whenever you call for 5 within the segment table, what comes out? Small business. All right, so I'm going to rename this index and call this segment ID. So this is the segment ID. And how do we rename? Just double click on the colon name and call the segment ID. So we've got the segment ID, and remember, for colons or attributes that I'm not going to be doing any summarization, I'm not going to be multiplying, I'm not going to be adding, I'm not going to be doing anything around this. It's safe to say that it's best that you choose text data type. So I'm going to go and choose data type, and I'm going to call this text. All right, so you can of course also move this to the very first arrangement, right? So we have the segment ID, we have the segment. All right, so now we need to tie this segment ID back to the fact sales, such that wherever I see a segment, right, I can also see its ID within the fact table, because that's the only way you can normalize this table. All right, right now you've got segments, you've got government, and several other things right within this record. So there's no way you can uniquely identify what is what back to the dimension tables. Okay, so how do we go ahead to do that, or how do we go about that? So I'm going to come back to my fact table, my fact sales, which I'm trying to normalize, and I'm going to come back to my home view. All right, there's something called merge queries. So I'm going to click on the merge queries, right? So the question is, what am I trying to link to the other table, to the dim segment table? I'm trying to link the segment, right, to the segment dim segment table. So what are you going to use to identify them? How would I then identify, that government is government in the fact sales? It is the government colon I'm going to use to identify that, because remember, currently we do not have segment ID within the fact sales. So I'm going to say select this colon, and then also select the segment colon within the dim segment, and I'm going to click OK. When you do that, you have a dim segment table ready for you to import or load within your fact sales. So if you see there's this button here, you're going to click on that button, right, which is the expansion button. And remember, now the question is, what are the information that I have within the fact sales, right, which is also presently on this expansion. I have the segment there already, so I don't need to import that again. What I need to import, right, will be just the segment ID. So you want to deselect segment and leave what you're importing. Then uncheck this one, this use original colon name as prefix, and then click OK. So right now, everywhere that I have a transaction within my table, fact table, I also have the applicable segment ID for that transaction. All right, so it is now easy for me to bind this fact table back to the segment table, the dim segment, right? So that's the process. So I'm going to then repeat the process within the dim discount bound. So I'm going to choose the colon, deselect everything. What are the things that you need that would point to the discount bound? Would be the discount bound. Is there any other thing? No. But if you check, you could also, of course, you could also say discount itself. But I don't want to do that because I know that discounts, as it were, could be, a measure, right, for every product. So I can always, just check for the discount band and then click OK for that. So now we have this pretty much this number of discount bound where I need to remove duplicates. You know that already. So I'm going to say remove duplicate. So we have uniquely 4 type of discounts band, right, within my table. So I'm going to then come here, as you know already, to add colon, and I'm going to choose index colon, and I'll say start from 1. So again, we're going to call this discount bound ID. Discount bound ID. I'm going to remove the space as a proper naming convention that I'm choosing to use. And we're going to bring this back to this place. I'm going to also change this type, of course, to text, right? So we're going to go back to fact sales to bind the dim discount bound table back to the fact sales. And how do we do that? We're going to say merge within on my home tab, merge queries. What are we merging? We're merging fact sales to the dim discount band. And where are we merging them? We're merging from discount band colons to discount band colon, and we're going to say okay. We're going to expand this, and we're going to just choose the discount band ID from the list and click OK. So now we have the targeted IDs for discount band. We're going to repeat that process again for product. Choose colon. What are the things we're choosing for products? I'm choosing the product itself, right? And I'm going to click OK. So I'm going to click OK. So we need to also remove duplicates. So let's right click and come here to remove duplicates. So now we have removed duplicates. The next would be to properly, create, as we said, add an index to this. So I'm going to come here, add index from 1. I'm going to call this product ID, product ID. And we're going to change this back to text. Change the type to text. I'm going to bring this here. I'm going to go back to my fact sales, and we're going to come to merge under the home. Let's merge. Let's look for what we're merging. We're looking for the product ID. The products from the fact sales, and we're clicking OK. We're going to expand this, and we're going to choose just the product ID and click OK. So now we have that. And lastly, location. So what are the things that point to location? So we're going to choose colon, deselect everything. Location is country. Do we have country code or country ID or city or anything? If we have nothing, other than just the country. So let's say, for instance, we have country, we have city, we have state. You're going to select those things that bind or that links you back to the country within the selection. All right. Okay. So we're going to click OK. We're going to, of course, remove duplicates. Right click on that, remove duplicates, and then add an index colon from 1, and then we're going to call this country code, country ID rather. I'm going to call it country ID. We're going to change this again to text, change data type to text. I'm going to move this to the front here, or to the back rather, and then we're going to go back to the fact sales. We're going to then merge, as merge queries. Location is the segment, which is a country, and then from the dim location, I'm looking at the country. then click OK, and expand this, right? Deselect everything, or just select country ID and click OK. So now we have everything pretty much sorted, right, with all the IDs. So the next process will be to remove all the information which would rather, be some redundancy within my fact sales. So what are the redundancies within my fact sales? You've got the segments, country. You have country ID already representing this. You have product. You have discount band. So safe to say you can remove all this, within your fact sales. How do we go ahead to do that? You know that already. We're going to choose colon. Why we're removing this is because we already have them represented elsewhere in our dim tables. So segment, you already know that you have segment covered within your dim segment. So I don't need the segment colons within this table anymore, right? So I'm going to just choose colon. I don't need segment again. I don't need country because I already have a dim country. I don't need product because I already have a dim product. I don't need discount band because I already have that as well. What else do we not need here? If you move on, we're saying that we have the segment ID, the discount band. Yeah, so pretty much we don't need those four column or attributes within this fact tables again. So I'm going to click OK. So now those things are gone, right? We've removed redundancy. So our table is a bit slimmer, right? The figures that you have here are mostly numeric figures and measures now that can in turn bind back to their respective dimension tables. The last thing we need to do here is to create a dim table query, right, using mQuery. So for the purpose of demonstration, I really have there's a site that you can make use of the mQueries that have been written, to do the dim table calculation. So this is the link or the URL. So I'm going to copy that URL. Then going to go to the site, create that, and then that lands you to this. If you click on that URL, the URL will point you to this link here. All right, so this is what I'm going to do. Just copy this within this code editor on the website. Copy all that. Copy all the queries that you have there. Control C, and then come back to my Power BI query editor. Click on New Source, drop down. Click on that drop down New Source, and then click Blank Query. So when you get this blank query, come to Advanced Editor to delete what you have here, right? Click Done. Then in front of the equal sign, paste that code there and hit enter on your keyboard. So now it's going to fire, a query, right? It's going to trigger a query for you to ask you basically, where do you want my date to start from, or your date, where do you want your date to start from, and where would you typically want it to end? So the way to do that is to quickly hover to your file, your sample file, and check in the date tab, in the date column, the year column, how many years or dates do you have within that. So you've got 2013 and 2014. So I'm going to come back here to say start from, I'm going to choose 2013, the very first day, very first month in 2013. So January would be, and then the end date, as you saw there, is 2014. But let's say this is a growing project. Perhaps you want to start maintaining the project, or you've been maintaining the project from 2013 down to 2022, right? So you could, safe to say that you could just come here, rather than choose 2013, I could then choose 2023 or even above, right? So the end of 2023 will be December, so I could pick December 2023, right? Remember, this is a continuous report that you want to create, so you don't want to be limited within just few years of selection. So I'm going to pick the last day of this year, and then I'm going to click invoke. So when you invoke that creates for you a dim date. I'm going to call this dim date. So pretty much straightforward, right? Then lastly, remember, you need to make some changes with the from the any data type, which are by default that comes along with the query, or some tables that you even import on the query editor. So I'm going to change them to this respective data type, so date is currently on any, so I'm going to right click on that and change the data type back to date, right? The year should be whole number, right? So I'm going to change data type for year to whole number. And then I'm going to change the quarter, what else? Month and day of week. Those should be what? Text. So I'm going to change them to text. Transform text. Then month number. So month number, which is week 1, month 1 should be whole numbers. So I'm going to right click on those. I'm selecting them using control. So if I hold on the first header and I click and hold on to my control on my keyboard, I could select multiple attributes or multiple columns, right? You know that, of course. So I'm going to then choose again whole number. So with this done, we've now successfully created what you call dimensional models, right, within our our fact table. A single denormalized model has now been normalized properly with the respective fact table, one table, and dimension tables. So with this done, I can close and apply, right? So it's going to typically then load all the tables to my query or my data pane. So let's look at what that table looks like currently, on my model view. So let's head on to model view right here. So this is what that looks like typically, right? So I've got, my Power BI has pretty much done the magic for me, almost done all the magic for me, of course. So it's pretty much arranged everything for me in a star schema arrangement. So if I properly bring them here, lay them all out, I have what looks like a star schema, right, with the fact tables right in the middle, right? You'll see the relationship is currently 1 to many. All the relationships that I have here has been normalized, so I have the 1 to many. This is what you want to ensure for every project that you're doing, that the relationship between them should be a 1 between your fact table and your dimension table or dim table should be a 1 to many relationship. Look at the point or the arrow. Look at the direction of the arrow. So it's from 1 to many kind of relationship, right? That's the cardinality. The list you want to have could be a snowflake, right? Or you have a bridge table. If you have, a many to many kind of relationship, you can have a bridge table between them so that you can normalize them. But we have one more problem here, or one challenge here, as well. So because we manually created our dim date, right, by importing that query, so the intelligence in Power BI is not able to detect what relationship to use. And let's see the implication of this in our data, in our reports view. So if I head on to my report, and typically we have your dim date. So let's pick, for instance, I'm interested in seeing the sales record across years. So I'm going to select years, right? And I'm going to choose, let's choose, table, right? So it's currently summarizing them. Let's change that from colons to do not summarize. So we have pretty much the query we invoked from 2013 to 2023. If I pull the sales across the years, right, into that table, let's just fire that into the table. Look at what happens here. Because there's no relationship between them, right, what happens, your Microsoft Power BI treated pretty much all the records as the same. So what it did was to summarize the total sales, and then in each year was just returning the exact number of sales, total sales, which is absolutely wrong, right? And why is this? It's because there's currently no relationship between my dim dates and my fact sales. Let's look at how to fix that. So if I head back to my model view, this is your dim date, which has no relationship, no bearing to your fact sales. How do we create a relationship here? So remember, we said that what binds our fact table sales, our fact sales table, to our dim date is what? Is the date. So I'm going to basically just pull the date from dim date and drop it on the date, exactly on the date attributes within my fact sales, and then allow Power BI to draw the magic for me. So right now we have the relationship created between the dim date and the fact sales. So if I head back to my report view, now we have that fixed for us. So now I'm able to see, pretty much the records by dates, and of course you can go on and on to do every other transformation or reporting that you want to do. So you find out that this way, your your reporting and the fetching of records by your Microsoft Power BI server, which is the engine that drives your current Microsoft Power BI desktop, would be pretty much seamless, faster, as against working from a single dimensional fact table, which is denormalized. So with this, we've come to the end of this walkthrough. I hope this makes sense to you, and I hope that in your subsequent project, you are able to start first by normalizing your denormalized model before starting your project analysis. All the very best in your next project. See you.